Hi everyone, we're starting with 3.1 polynomials, functions, and their graphs. One of the things we're going to be looking at is how the graphs behave today. So if we look at our first example, it says use your graphing calculator to help you graph the following functions and answer the questions. So I'm not going to use a graphing calculator, I'm actually going to use a web page. So let's go ahead and do that. Our first graph is going to be x squared. As you can see, that's the parent function. Notice that we have a y-intercept at 0. Also, we have x-intercept at 0. Notice how the function is going up both directions. So if we go ahead and start answering these questions, we will see a little bit closely what we need to fill in. So it says the x-intercept, as we looked at it, was 0. So that's going to be 0. Y-intercept was also 0. Now notice as the y increased, if we look at our picture here, if we go ahead and graph that, we had our function here at 0, 0. Now if I plug in 1, I will get a 1 as a result. If I plug in -1, I will also get a 1. If I were to plug in 2, I'll get +4. And if I will plug in -2, I will also get +4. So here's my graph. Now as you can see, if we look at what's going on, we have y, as y goes to positive infinity. So as y goes to positive infinity, x also goes to negative infinity on this left side. So notice that x is going negative infinity here. And as y goes to positive infinity on the right side, you also have x going to positive infinity. So you have two cases where you have y go to positive and x goes to negative. So they're both going up in that direction. Now if we look at our next one, if we go back and look at our calculator and we go ahead and delete and bring that to the third power, notice we get this squiggly function here. As you can see here, it actually looks like an S or inverted S. So let's go ahead and look at our x-intercept on that one as well. Notice our x-intercept here is also 0, so we'll go ahead and fill that in with the 0. Same thing with the y-intercept, we're going to go ahead and fill that in with the 0. Now let's go ahead and actually graph this. So by graphing this, I'm going to go ahead and get 0, 0 as my x and y-intercept. I will also, if I plug in 1, I'll get a +1 here. And if I plug in -1, I will also get a -1. Now, if I plug in a +2 here, notice that it will go 2 cubed, and 2 cubed is actually +8. So it will take me all the way up here. And if I plug in -2, it will be the same thing except -8. So now, as you can see, my function is going to go from here, go down through that, kind of like an S. Obviously the computer did a better job than I did, but as you can see, my left hand side behavior, as the y goes to negative infinity, notice that my x is going to negative infinity as well. Now on my right side, as y goes to positive infinity, my x is also going to positive infinity. So we can clearly see the right side is going up to the right and up. That's positive to the y and positive to the x. On the left side, both x and y are going to negative infinity. Let's go ahead and look at our next function. So if I go ahead and graph that one, again, take x to the third and delete the 3, put a 4 in there. that actually looks very similar to our function that's x squared, but notice that the bottom is a little bit flatter, so it does give us a little bit of different function. And notice our x and y intercept is still at 0, so we're going to go ahead and continue writing that. So that's 0, and that's also 0. Now notice that if I go ahead and graph that, we will get the following: 0 will be 0, so that's no questions there. Now if I take 1 and I go ahead and take that to the 4th power, I will get 1 to the 4th. Let me actually pause this for a second. Alright, as you can see, if we go back and look at our graph here once more time, notice that even though it's flatter, we still get 1, 1 gives us a value here, that's 1, 1, and negative 1, 1 is still here. But if you notice, just in the fractions is where it gets really flat. So when we go back and graph this picture here, we're still going to get a 1 at 1 and then negative 1 at 1. But at 2, notice it's raised to the 4th power. So 2 raised to the 4th power is actually 2 times 2, which is 4 times 2, which is 8 times 2, which is 16. So it actually goes off the charts. But if I'm going to draw this, I'm going to draw this a little bit flatter here, and then I'm going to shoot up, and then a little bit flat here, and then I'm going to go up. And again, this is not the best representation of this graph, but you get the majority or the main idea of this graph. So it looks like a parabola, it's a little flat on the bottom, and then it shoots up. Now let's go ahead and actually look at the values for y. So on the left side, notice y is going to infinity. So as y goes to infinity, notice x is also going to infinity, just like the parabola. Now on the right side, as y goes up, we see that y is going to infinity. We notice that x is also going to infinity. So in this case, both of them are going to infinity. I do apologize, this actually goes to negative infinity because it's going to the left. Now d, again, this is x raised to the 5th power, so go ahead and look. Let's go look at that graph right now. So if I give it a shot, so let's see, to the 5th power, notice it's very similar to the same concept as x to the 3rd, but in this case it also flattens out right here, but you still get 1, 1, and negative 1, 1, and positive 1, 1. But it's just a little bit flatter, just what happened with x to the 4th. So, but we can see that this is still 0, that's still 0. So if we go ahead and graph that, we'll get this at x here. We're still going to get 1. We're still going to get 1 here. When we plug in 2, it's just going to shoot up to 32. So it's going to be very, very steep, but it's going to get flat here. So it's flat through this area, and then it's going to go up really, really steep here. And again, it's going to be flat here, and then it's going to go really, really steep here. So as you can see, kind of flats now, but you get the idea with the graph. Now notice if we look at the left side, notice the y is going to negative infinity, so is the x. Both of them are going to negative infinity. On the right side, as y is going to positive infinity, we can see that it's going up. X is also going to the right, so that would be positive infinity. So this kind of covers the behavior of the function. Now, the degree of the polynomial, that is defined as the highest exponent. So the highest so that'll be the highest exponent. Let me write something larger, I think will be better. Now, leading coefficient, that would be something we call the term in front. So the term in front we'll talk about, so I'll give you an example of that. If I have some kind of a function, let's say negative 3x to the fourth plus 2x squared minus x plus 10. So our leading coefficient will be the negative 3. Remember, it's the front term. Our highest exponent is going to be 4. So the degree of that function is going to be 4. The leading coefficient is going to be negative 3. We also call that leading coefficient A, and that's what you see here. This is what the definition is coming from. So if you have an even degree, like x to the fourth power, that's an even degree. If you have an even degree and a is positive, in this case, in this example that I gave you, a is negative. So if a was to be positive, or if it was positive 3, not negative 3, then the end behavior, or we call the end behavior of the functions, where the function is going to be going, is both up. So this is like a parabola going up, x squared. Notice a would be positive and they'll be both going up. If a happens to be negative on an even function or even degree function, just like the example I gave you, so if we went and graphed this, this would be where an end behaviors would be both going down. So again, end behavior is both down. If a is positive on an odd degree, and again this is like x to the third, so it looks like an s. So if that's the case and a happened to be positive, let's say we had 3x to the third power or 3x to the seventh power, if that was our leading coefficient, then in this case the end behaviors the right side is going to be going up, but the left side is going to be going down. So the right side is going to be going up and the left side is going to be going down. So this is going to be very similar to the examples we have here. The right side is going up, the left side is coming down. Now if we look at a and it's an odd degree, so it's like x to the seventh, and you have like negative 2 or negative x to the seventh. So if it's negative, then the end behavior is going to switch on you. This is where the left side is going to go up this time and the right side is going to go down. So a quick example of that will be, so let's look at this behavior here. Let's look at even degree with positive coefficient. So if I look at using the Desmos, here's a even degree. Okay, let's change it to even degree. Let's say 6, and then we have the coefficient, let's say 2 there. So the 2 is positive, x to the 6. Now if I change that to a negative, notice it will both go down. And again, I can do the same thing. If I change this to, let's say, 7th degree, so notice that our right side is going up, our left side is going down. But if I change that coefficient to a negative, notice now our right side is going down, but our left side is going up. So this is what it's telling you. This is what's happening when you have those even degrees and positive and negative coefficients, leading coefficients. Alright, so that takes care of our problem there. A function can change direction as many times as n minus 1 for polynomial in degree n. This means it could have n minus 1 local extremas. Okay, an extrema is either the local minimum or a local maximum. Now, what this basically means, if you have x to the third power, your function could have two local minimums or two local maximums, depending on the kind of graph you have. So if we look at this example here, we have x minus 1 squared and then times x plus 2. Notice that if I were to actually factor these or distribute these, my leading coefficient, okay, is going to be x to the third power. Now, this will be x to the third power as my leading coefficient, which means a couple of things. If we go back here, if it's odd degree and it's positive, that means my right side is going to be going up, which it is, and my left side is going to be going down. But more importantly, notice that I have n minus 1 local extremas. So notice that my n is my degree, which is 3. Minus 1 gives me 2. So I have 1, 2 of maximum and minimum. So we have 1 maximum and 1 minimum. So that's what this is telling you basically. So now let's go ahead and figure out a couple of things. It says the graph of the function is provided. State the x and the y intercept and the local extrema. So let's go ahead and do that. Let's start with our x. I think that would be a good way to start. So let's go ahead and do that. So our x intercept, we have two of them. We have a x-intercept here, and we have an x-intercept too here as well. So that would be -2, comma, and +1. Our y-intercept, as you can see, is at +2. So we can write +2. Our max is going to be here. That's our max. That is located at -1, +4. So that's exactly how we're going to write it. -1, +4. And our minimum, or local minimum, is going to be located in this where we already have the dot, which is 1, 0. So that gives us an idea where the x and y intercepts are, and max and mins. Now let's go ahead and look at our next example. So our next example, as you can see, we can go ahead and look at our leading coefficient. Think about this just real quickly. If I took this x, multiplied it by that, that's going to be x to the third, and then I multiply it by that, that's going to be x to the fourth. So my leading coefficient is actually x to the fourth. Now I don't have to multiply all of that out to know that, but I can see that my leading coefficients, or my leading numbers, is going to multiply to x to the fourth. Now, having said that, remember, if I have an even degree, which I do here, x to the fourth, and it's positive, that means both of them has to be going up. As you can see, both n behaviors are going up. So that is still representing what we talked about before. Now they do want us to go ahead and identify the x-intercepts and the y-intercepts, and then the maximum and the minimums. So let's go ahead and do that. And again, for some reason my pen is switching, so let's go ahead and figure out what our max and our mins are. So our first thing, let's go ahead and start with x is x-intercept. So let's start there with x-intercept. So my x-intercept is going to be here, there, and there. That would actually be -2, 0, and -2. Now my y-intercept is going to be only at 0. That's the only location where it crosses the y-axis. Now I do have one max and I do have two mins, so let's go ahead and find the max first because that would be easier. That is at, as you can see, 0, 0. My minimum, there's two of them. The first one is looks like -1.5, so about -1.5, comma, and at -4, so it's right here. The other one is also at +1.5 and -4. So that gives me my values there. Alright, let's go ahead and look at our next rule, if you want to say that, but something that explains how the functions behave. It says multiple zeros occur at c, and the c variable is the one when we have like x minus c. So in other words, something like this, x plus c. So that's kind of what you're looking at. So the c is that root, if you will. If I was to solve that for 0, I'll get x is equal to -c, which means will be my root. So c is my root, or x, that's going to be one of my factors. So c is when the factor x minus c occurs more than once. The multiplicity of c would be the number of times it occurs as a factor. This multiplicity determines how the graph reacts at the x-intercept. So let's go ahead and look at example number 2. It says find all the x-intercepts and the polynomial functions. Now notice that I can actually rewrite this function as the following: x minus 1 times x minus 1 because it's being squared, and x plus 2. Now if I set them equal to 0 and I solve for x, I will get x is equal at 1. I'll get another one, x is equal 1, and I will also get x is equal to -2. Now we don't repeat these, so we're just going to write x is equal 1 and -2. So if I asked you to find the roots, that would be your answer. However, these roots actually tells you how the function behaves, because since we know that it has a root at -2, we can put -2 here, and we know it has a root at 1. But notice what it says: if c has an odd multiplicity, then the graph goes through the point. Notice we only have one x is equal to -2, which means my graph is actually, or has to go through that point. Now notice I have two x1s. That's an even amount. If that's the case, if you read the next statement, if c has an even multiplicity, then the graph touches the point. It doesn't go through it, it touches. So what this actually means is that at this point it has to go through the point, but at this point it's only going to touch it. Now I also know that when I multiply these out, my leading coefficient is going to be x to the third. So if we go back and look at that, well, what does that tell us? Well, if it's an even, okay, if it's positive and it's an odd degree, that means my right side is going to be going up, my left side is going to be going down. So left side is going down, as we can see there, because it's going through -2. But my right side has to be going up. Well, the only way to do that is if it touches it but never crosses it. So it's something like that. So at -2, it goes through -2, but at +1, it's only going to touch it and then bounce back up. So that's what these mean. So if we look at our next example, B here, we have a similar situation here where I would have to factor that. So to do that, I would have to factor by grouping. So get those factors out. So notice in the first example here, I can factor out an x to the third, which will leave me with x plus 2. Now from the second, I can factor out an 8, positive 8. Then that would leave me with x plus 2. And as you can see, this factors to x to the third plus 8. That's going to be my one factor. And my second factor is going to be x plus 2. So if I set them equal to 0, I can solve each one. This one will solve, we'll get x to the third is equal to -8, which will actually get x is equal to -2. Because when you take the root, the third root or cube root of -8, you get -2, positive, and negative. Actually, it's just going to be negative because it's not even. So yeah, cube root will be just negative. Now when we solve x plus 2, we'll get the following. We'll get x is equal to -2. Now notice there are 3 of these and 1 more of these. So there's actually an even amount of x to the -2. So there's really just one root and it's at -2, but there's 4 of them. X to the third, there's 4 of those, and x to the third, there's 3 of those, and then obviously the second one here. So there's 2 of them, which means we can have a function that is leading coefficient is x to the 4th. So that means both of them are going to be going up. So this is a function that looks something like that. It only touches at -2. It actually never crosses -2. So this would be like a parabola looking function. Which brings us to the next example. This is where they would ask you to sketch the graph. Notice they're saying do not use a graphic calculator. You basically have to use the knowledge you just learned how the functions behave, and you'll be asked to go ahead and graph them just from what you can figure out yourself. And because it's a sketch, it doesn't have to be perfect. It just has to represent the function pretty well. And we know how the end behavior works, and we know all of that other stuff. So we want to draw some x-axis, and we want to draw the y-axis. And then we're going to go ahead and figure out what we'll do from there. So let's go ahead and do that. So let's talk about what do we have. Well, we can tell what the x-intercept is. That's easy. To find the x-intercept, we have to make y equals to 0, which actually will give us 0 here. To find the y-intercept, we have to make x equals 0, which gives us 0 as well. Now let's look at the end behaviors. So the end behaviors, or behavior. Well, what do we have? Our leading coefficient is -x to the third, which actually tells us that we have an odd function, which means one of them is going to go up, one of them is going to be going down. And since our A, or the leading coefficient, is a negative, and we go back and look, if you want to refresh your memory what that is, remember it's an odd and it's negative, which means the left side has to go up and the right side has to go down. So in other words, the right side has to be going this direction and the left side has to be going that direction. But remember, because it's an odd function, it's going to look like an S. So if I was going to draw that or approximate it, I know it has to go through here, but if I drew this, it would look something like that. And again, this is a sketch. It doesn't have to be perfect. So, but you should be able to give me at least that as your function. Now, if I look at this problem here, notice a couple of things. If I were to actually factor them out or distribute them out, my leading coefficient would be x times x times x, which is x to the third. So again, that means it's an odd degree, and the leading coefficient, or A, is actually positive. So having said that, we're going to have to decide a couple of things. Let's find the x-intercept first. And again, to find the x-intercept, I would have to replace g of x with 0. So something like that would look 0 is equal to x plus 1 cubed. Well, taking the cube root of 0 and the cube root of those cancel, you still get 0 is equal to x plus 1, which gives you x is equal to negative 1. So our x-intercept is negative 1. Our y-intercept is going to be replace x with 0, so that 0 plus 1 cubed is still going to be 1. So that's going to give us a positive 1. So now let's look at the end behaviors. And behavior. And remember what we're looking at. Okay? Here we're going to have, like this here, the example A, we had a left going up and the right going down. In our case, because it's in positive and odd, so it was odd here, but it's now positive here, it's going to switch roles. The left side is now going to be going down, but the right side is going to be going up. So let's show that real quickly. First thing you have to do is label your x and y intercept. Remember, your x intercept is at negative 1. Your y intercept is at positive 1. So, and remember, the right side is going to be going up, so it's going to be doing this. And then the left side is going to be going down, so it's going to be doing that. So as you can see, again, it's going to be inverted S, if you will. Alright, let's go ahead and look at C. Before we can solve this problem, we do have a leading coefficient and we do have a degree, so that tells us something about the graph. But I still want to get my roots, so I would have to factor out a 2 to get x squared minus 1. Notice that this is difference of squares, so that would be x minus 1 and x plus 1. That factors to that, which then tells me that my x intercept, if I set this equal to 0, will be x is equal to 1 and negative 1. So negative 1 and positive 1. Now my y-intercept if I go ahead and set that equal to that, we get negative 2. Because if I set x is equal to 0, that will be 2 times 0, which is just negative 2. So my end behaviors. Let's look at that. It's an even function, so it's either going to be going both up or both down. Since the 2 is positive, this is going to be both up. So to draw that, again, draw your x and y. So now let's go ahead and show us our x-intercepts. Notice my x-intercepts are going to be at -1 and +1. My y-intercept is going to be at -2. So it's going to look something like that. A function that looks something like that. It's a parabola that's going up with y-intercept at -2 and x-intercepts at -1 and +1. So let's go ahead and look at one more example here. So before I can actually solve, before I can get started on this, I need to solve this for my roots, so that way I know what my roots are. So again, if I set this whole thing x minus 3 squared minus 4 is equal to 0, that way I can solve for x. So let's go ahead and do that. We get x minus 3 squared is equal to 4. Then take the square root on both sides. Square root, square root. We get x minus 3 is equal to plus or minus 2. And that will imply that x is equal to, if I add the 3, 2 plus 3 is 5, but negative 2 plus 3 would be 1. So my x-intercepts are going to be at 5 and 1. My y-intercepts, remember this time I have to set x equals to 0. I would have x is 0, so that'll be 0 minus 3, which is -3. -3 squared would be 9, and 9 minus 4, my y has to be 5 then. So end behaviors. Will actually be both up as well, because my leading coefficient will be x squared, so that'll be both up. So let's go ahead and sketch this graph. And again, when we talk about sketching, it does not have to be perfect. It just has to represent it pretty well. So x-intercepts are going to be at positive 5, 1, 2, 3, 4, 5, and at positive 1. My y-intercept is going to be at 5, 1, 2, 3, 4, 5. So now it's going to be a graph. Again, we can actually also, by looking at this picture, we know where the vertex is. Notice that this is in vertex form. So I know the vertex is going to be at, remember inside lies, so it will be 3, -4. So that actually allows us to find where the vertex of that graph is. So it will be 3, -4. And now I can go ahead and graph that. So you're going to have it going this way, and you're going to have a graph going that way. So that gives us the sketch of that graph, pretty accurate actually, of that graph. because this was in a vertex form, we were able to find the vertex as well. So for example E, we're actually going to have to factor by grouping again to find my x-intercepts. So let's go ahead and do that. So to find the x-intercepts, I would have to factor by grouping. So in the first one, I would factor out an x squared, which will leave me with x minus 2. In the second group, I can factor out a negative 4. So we definitely want to factor out that negative to make that x positive. So we get x minus 2. And the two factors that I will get will be x squared minus 4 and x minus 2. Now if I set them both equal to 0 and then I solve them, notice that this factor here will actually factor out to, it's a perfect squares or difference of squares. So we actually can factor that out to x plus 2 and x minus 2. And we still have this x minus 2 here is equal to 0. Then notice if I set them all equal to 0, I'll get my x-intercept. So my x-intercept will be x is equal to negative 2 and positive 2. Now my y-intercept, if I set my x equal to 0, I just get a constant, which is the 8. So y-intercept will be 8. So let's talk about the end behavior. The end behavior. Notice that our leading coefficient is x to the third, which means we know that one of the sides is going to be going down, the other side is going to be going up. The question is which one? Because it's positive, we know that the left is going to be going down. We also know that the right side is going to be going up. Now let's go ahead and graph that. So your y-intercept and the x-axis. So let's talk about where my points are. Notice that my x-intercept, I have a negative 2 and I have a positive 2, and my y-intercept is a positive 8, so that's 1, 2, 3, 4, 5, 6, 7, 8. The question is, how is this graph going to look? And this is what helps to go back and remember that we do have a couple of things. We know that if we have odd or even number of roots, those will actually either going to go through the point or bounce off the point. So I do have a negative x equals negative 2 and x equals x minus 2 is equal to 0 and x minus 2. So that's an even number of roots and that's an odd number of roots. Now notice that x plus 2 actually equals to negative 2 and x minus 2 actually equals to positive 2. So since I have an even number of positive 2 roots and I have an odd number of negative 2, which means left side is going to be going down, it's going to be going through that point, but it's going to bounce off the positive 2. So this is what we talked about in that previous problems or previous examples. Because I have an even number of x minus 2's, which gives me positive 2 as the root, it's going to bounce off at positive 2. But since I have an odd number of x plus 2, which is negative 2 as my root, it's going to go through negative 2. And so that's how I get that function. If you want to check your answer, go ahead and take a calculator, plug that equation into calculator and graph it, and you'll see that it actually works. So these behaviors that we're talking about, we're not just making this stuff up. This is how they actually work. Alright, let's go ahead and look at our next one. Again, to find the x-intercept, we have to set x is equal to 0, or we're actually going to go ahead and say negative x to the fourth plus 16 is equal to 0 to find all my roots. So then I would have negative x to the fourth is equal to negative 16. You can divide by negative on both sides. You get x to the fourth is equal to 16. And then if you take the root 4 on both sides, root 4 on both sides, the to the fourth power and the root 4 will cancel each other out, and you'll actually get x is equal to, and this is the one you do get plus or minus 2 because it's an even degree, so it's going to give you plus and minus, which tells you that x-intercept is going to be at negative 2 and positive 2, which also tells you that y-intercept, if we plug in x is equal to 0, so if x is 0, so that would be 0 to the fourth power 0 times negative still 0, so that would be 16. So to make our life a little bit easier, I'm actually going to count each square by 2 here, because we do have a y-intercept at 16. So rather than making that as a 1 unit, I'm going to make it 2. So this would be my x-intercept will be at positive 2 and negative 2. Again, I'm making this each box as negative 2, which also tells me why my y-intercept is going to be at positive 16. So that will be 2, 4, 6, 8, 10, 12, 14, 16. So the end behavior for this one, since it's even degree, it's going to either go up or go down. Since it's negative, you know it's going to be both down. So therefore, I will draw something of that sort, a parabola that's going down. And that will conclude our lesson for today.